In everyone's heart lies an insatiable curiosity, a deep desire to know and discover the mysteries of the world. This quest for knowledge leads us to examine the context of our surroundings and explore the complexities and functions of the celestial bodies that populate our neighborhood. Ever since our eyes looked up to the stars, we are eager to categorize and understand the dimensions of everything around us. But when we look beyond the known borders of Earth, the challenge of understanding the vastness of space lies before us. Questions about the size of our solar system and the universe at large are among the most important questions in modern science. What problems arise when trying to measure the world? What new discoveries have scientists made about these phenomena? Join us on this exciting journey to discover the secrets of our galactic home. As we begin this exploration, it is important to begin with our cosmic environment, the solar system. The solar system is a beautiful collection of celestial bodies, all bound together by the gravitational pull of the Sun, our central star. The Sun, which makes up more than 99% of the total mass of the system, acts as an anchor around the planets, moons, dwarf planets and thousands of smaller bodies such as comets and asteroids. There are 8 known planets in the solar system, and they fall into 2 main categories: the terrestrial planets, which include Mercury, Venus, Earth, and Mars, and the atmospheric giants, Jupiter and Saturn, Uranus, and Neptune. This classification shows the major structural differences between the rocky inner planets and the outer gas giants. For example, although the terrestrial planets have solid surfaces, most of their atmospheres are light gases such as hydrogen and helium. When we consider the size of our solar system, we realize that measuring its vastness is more difficult than it first appears. The distance between the Sun and Neptune, the most distant planet in the solar system, is about 3 billion miles. However, this measurement does not accurately reflect the size of the universe, as it does not take into account the number of dwarf planets and asteroids in the trans-Neptunian region, which is also affected by the gravity of the Sun. In fact, as can be seen from above, almost all the celestial bodies in our solar system revolve around the Sun in a clockwise direction, with a few exceptions, such as Venus and Uranus. Each planet has its own unique orbital period, determined by its distance from the Sun. Earth takes about 365 days to complete one orbit, while Mercury, which is much closer, only needs 88 days. In contrast, Neptune takes 165 years to rotate one day. When we look at the movements and complex relationships between these celestial bodies, a burning question arises: how big is the solar system? The answer to this question is somewhat obscure. At this point, we don't know. The scientific community has no definitive criteria for the end of the solar system. In the past, many believed that the heliopause, the outermost region of the heliosphere, marked the edge of the solar system. The heliosphere is the region of space where the solar wind is dominant, a constant stream of particles emitted from the Sun. This region is estimated to be 9 billion miles from the Sun. However, recent observations have shown that extra-Neptunian structures outside the heliopause are bound to the Sun, challenging the hypothesis that the heliopause is the outermost boundary of the solar system. Therefore, determining the exact extent of the Sun's influence requires in-depth research and complex topics. As we grapple with the uncertainty of measuring the solar system, the problem of measuring the universe at large takes on a new layer of complexity. There are many challenges in this important role. First, we need to understand the structure of our world. While some scientists say the universe is spherical in shape, others say it is flat or annular in shape like a bag. These different assumptions show that the scientific community has not yet reached a consensus on the geometry of the universe. Also, the world does not stand still. It's still expanding. This spread complicates our efforts to determine its full extent. In the early times after the Big Bang, the rate of expansion of the universe slowed down, but since then it has increased, leading scientists to propose a theory of dark energy. This horizontal form of energy is thought to prevent gravitational forces, allowing the universe to continue to expand at an ever-increasing rate. The idea that the size of the universe can go to infinity makes measurements more difficult. It is very important to distinguish between the concept of infinity and infinity. If the universe were a sphere, it would represent a finite volume, but still contain infinite space. In this context, circular surfaces have no defined center and can move indefinitely without reaching a concrete edge. However, according to the prevailing scientific hypothesis, the world is not grouped in a higher place. Thus, although our understanding of the spherical universe is a simple model, it does not capture the true complexity of cosmic structures. Despite these challenges, scientists have made significant progress in defining the observable universe. This range is limited by many factors, including our position in the world and the technological tools available to us. Currently, the most advanced telescopes can look 13.8 billion light-years into space. A light-year, the distance the moon travels in a vacuum in 1 year, is equal to 6 trillion miles. However, due to the late speed of the moon, our observations have been delayed. When we look at distant galaxies, we see the past. For example, a galaxy a billion light-years away is the same as a billion years ago. As a result, the end of our visible universe is not 13.8 billion light-years away from us, but extends to 46 billion light-years, which is the cause of the constant expansion of the universe to beyond the limits of the moon. The results of these findings are surprising. As we continue to explore the vastness of the solar system and the universe, we face profound questions about our place in the universe. How does the size and composition of celestial bodies affect our understanding of the world beyond Earth? What discoveries await us in space? As we stand on the precipice of knowledge, we ask you to think about the global scale. Your thoughts and opinions are important as we pursue this never-ending quest for enlightenment. Join this adventure and discover the secrets of our home galaxy. As we go deeper into exploring the universe, it becomes more and more clear that our understanding of its aspects is not merely an academic exercise. It has a great impact on people. Each discovery we make of the vastness of space not only expands our knowledge, but also inspires wonder about our existence and the possibility of life beyond our universe. The vastness of the universe challenges us to rethink our place in it, raising the question of whether we are alone in the universe. As we develop new technologies, such as telescopes and probes, we open up new avenues of exploration, revealing distant galaxies, exoplanets and lifelike planets. With each mission, we get closer to answering the most important questions about the origin of the universe and how it is. In addition, the ability to understand global trends strengthens international cooperation and inspires future generations. Scientists, astronomers and scientists from all over the world unite in a common cause to push the boundaries of human knowledge. Future projects like the Hubble Space Telescope and the James Webb Space Telescope are symbols of hope and innovation, reminding us of what we can achieve when we work together. These collaborative efforts not only lead to discoveries, but also foster a sense of global community and encourage us to protect our planet as we explore the wider world. As we look to the future, space exploration remains a symbol of human ingenuity and power, encouraging us to embrace the unknown and travel. Continue our search for knowledge in the endless expanses of the world.